Okay, part 2 now says to find the coordinates of the stationary point on the curve and determine its value. So this is my version of dy by dx from part 1. So the coordinates of the stationary point come from when dy by dx equals 0. So we need to make this equal to 0 now. So minus 2 3t squared take 3 times 2 plus t to the 3 over 2. That's a 3, that's a 2, equals 0. So the minus 2 we can ignore. So either 3t squared take 3 is equal to 0, or 2 plus t to the 3 over 2 equals 0. So if you solve this, the 3's can cancel and we get t squared equals 1, so t is plus or minus 1. If we solve this one, 2 plus t needs to be 0, so t is minus 2. But so there's 3 stationary points there, but if you look carefully, we won't actually get stationary points at 2 of those places. The only station, because this is t is greater than minus 2, it can't equal minus 2, so this solution doesn't count, and t stops at 0, it doesn't get bigger than 0, so it can't be positive 1. The only point that there's a stationary point is when t equals negative 1. We don't stop here though, because it wants the coordinates, so that means in terms of x and y. So if we now substitute in t equals minus 1 in for x and y, we will get what we need. So when t equals minus 1, x is equal to, it was 1 over the root of 2 plus t, so 1 over the root of 2 take away 1 is 1, and y was equal to t cubed take 3t. So that's minus 1 cubed take 3 times minus 1, which is minus 1 plus 3, so positive 2. So the actual stationary point appears at 1, 2. Okay, so then the second part asks us to determine the nature of the stationary points, or the stationary point, sorry. So in order to do that, we're going to need 2. Normally, we would find the second derivative and substitute the value of x in, but the problem here is that we've got dy by dx in terms of t, not in terms of x. So that's going to cause a few issues. The way I reckon we're going to do this is to check the gradient either side of the stationary point. So we're going to check the value of the gradient at x equals 0.9. We're going to find dy by dx, and we're going to check it at 1.1, because we know when x is 1 that dy by dx is equal to 0. So if we check it at 0.9 and 1.1, we'll be able to find the sign of the gradient, so we'll know whether it's negative or positive on the 2 sides of the stationary point. So that will be able to tell us whether we've got a max or a min. So we need to find out these 2 values, but again, this is in terms of x, not in terms of t. So we've got 2 options. We can either work out what t is when x is equal to 0.9 and 1.1, or we can rearrange this and substitute this into what we've got here for t, and that's the option that I'm going to take. I'm going to make this dy by dx in terms of x rather than in terms of t. So to do that, we know that dy by dx is equal to minus 2 times 3 lots of t squared take 3 times 2 plus t to the 3 over 2. And we also know that x is equal to, what's x equal to? X is equal to 1 over root 2 plus t. What that means is that if we rearrange this, that root 2 plus t is equal to 1 over x. So 2 plus t is equal to 1 over x squared. And t is equal to 1 over x squared take 2. So we can say now that dy by dx is equal to, and I'm going to swap t for 1 minus x squared over 2. So we've got minus 2, 3 lots of 1 over x squared take 2 squared take 3. And then we're going to have 2 plus 1 over x squared take 2 to the 3 over 2. Now this doesn't simplify very much, or I'm not going to bother simplifying it, but this simplifies loads. We're going to have minus 2, 3, 1 over x squared take 2. You could simplify that, but I'm not going to bother because we're just going to substitute a number in. But this is going to become, the 2's are going to cancel, and 1 over x squared to the 3 over 2 is going to become 1 over x cubed. So we're going to have minus 2 over x cubed times 3 times 1 over x squared take 2 squared take 3. So now what we can do is we can put minus 0.9 and 1.1 into here and find the values. So when x is 0.9, dy by dx is, I'm obviously going to do this on a calculator, so I'm going to use the last answer button. I'm going to type this in to my calculator and type the answer button when I see an x. So minus 2 over ants cubed times the 3 times 1 over ants squared minus 2 all squared take 3. Then I'm going to press equals, and then I'm going to type in 0.9 and equals, and then up and equals. And that's giving me a positive gradient. That's giving me 3.41. We know that when x is 1, we get a dy by dx of 0. You could at this point test that. You could check that when you put 1 in there, you do get 0. That will tell you that you've rearranged this correctly. And we do. And then I can press, because we've already kind of stored that formula, now if I type in 1.1 and equals, and then up to get the formula back and equals, we're getting a gradient of negative 1.7. So the fact that that's negative and that at 0.9 it was positive tells us that we've got, if you think about it, our 0 gradient at 1, at 0.9 we've got a positive gradient, and at 1.1 we've got a negative gradient. Obviously this would be a curve, but that's what we're getting, and you can hopefully see that we have a maximum point. Now, as I said earlier, you could, instead of doing what I've done here, you could have worked out the value of t when x is 0.9 and substituted it into our equation involving t, and done the same with the 1.1. It doesn't really make much difference it's kind of swings and roundabouts. It's 50-50. It's whatever you choose to do, really.